Hi dear students, today I'm going to teach you how to plot the graphs of trigonometric functions. The form of the trigonometric functions is this one, the blue one. Y equals a sine of bx plus c plus d. Later on I'm going to explain you what is the meaning of a, b, c and d. We're going to keep working with functions of sine and cosine, okay? What we're going to see today in this example is the function for the most simple sine function, which is y equals sine of x, okay? First of all, I want you to pay attention here to the unit circle. And I want you to remember that when we have an angle of 0 pi in radians, we have the point 1, 0, which is in cosine 1 in sine 0. Remember? When we have an angle of pi halves, we have 0, 1. When we have an angle of pi, of 1 pi, we have the point minus 1, 0. And when we have an angle of 3 pi halves, we have the point 0, minus 1. And this one, when we have an angle of 2 pi in radians, the point is 1, 0, 2. So with this information in the unit circle, we are going to create our table, okay? We are going to do this table just for this function, because when we keep solving more difficult functions, we are not going to do this table, but we are going to do all this other process, okay? Now, but this one is going to help me to explain you how you are going to plot the graph, okay? Now, instead of arc of x here in the first column, we are going to plot to write the values for the angle. Remember that theta is our angle. And when theta equals 0, I mean 0 pi here. Let me write pi, sorry. Okay, 0 pi. Sine of theta equals 0. Where do I get this value? From here, dear students. When theta equals 0 pi, sine equals 0, okay? And then when theta equals pi halves, sine of theta equals, look, 1, okay? And then when theta equals pi, here, sine equals 0 because it is this coordinate. And then when theta equals 3 pi halves, sine of theta equals minus 1, which is here. And when theta equals 2 pi, here, sine equals 0. Okay, so as you can see, all the knowledge that you have gotten is going to help you to understand this topic. Good, now, let's plot all the points that we are getting here in our graph. Look, here we have the x-axis and the y-axis. And also, it is important for you to know that in the x-axis, I am going to write the values for theta. I mean, 0 pi, which is going to be here in the origin, then pi halves, which is going to be here. Instead of numbers, I'm going to write the values for theta, okay? And then I have, look, we have pi halves, pi, 3 pi halves, and 2 pi, which are all these values, okay? And then in the y-axis, I am going to write the values for sine. I mean this column, okay? So as far as I can see, we have 0, 1, 0, minus 1, and 0. So I'm going to write here 1 and then minus 1. I have here the 0. And then we start plotting the points. In the first one, we have in 0 pi, we have 0 in the y-axis, okay? Which is this point. And then we have in pi halves, in sine of theta, we have 1. I mean in y. Okay, so in pi halves, we have this point in 1, in the y-axis. And then the third one is pi and 0, pi here in the x-axis, and 0 in the y-axis. Then 3 pi halves in the x-axis, and minus 1 in the y-axis, which is this point. And then 2 pi in the x-axis, and 0 in the y-axis, which is this one. Look, we have to plot always in functions 5 points, so you don't get lost, okay? 1, 2, 3, 4, 5. And once you have your 5 points, you trace the waves, the sinusoidal waves. Here you can see. But it is important for you to know that this is a period. Later on, I'm going to explain you what is a period, or, well, it's okay. Right now, a period is when you have one maximum point and one minimum point. It could also be named as one crest and one valley, okay? Once you have one crest and one valley, you finish the period. I mean, here and here, okay? Then, other important thing is that, talking about the domain, these waves are coming from the infinity and they continue going to the positive infinity, okay? So this is just the period where related to this function. But the real thing is that the domain in all the trigonometric functions is going to be from the negative infinity to the positive infinity, okay? Now, let me explain you this part, because when I give you other kind of functions, I mean more complex functions, you have to do all this analysis so you can start plotting the graph, okay? Let's start with the number 1. As you can see, I number all of them so you don't miss anything, from 1 to 9. The first one is the amplitude. What is the amplitude, dear students? The amplitude is the distance or the measure from the x-axis to the crest or to the maximum point, and from the x-axis to the valley or to the minimum point, okay? So I mean it is this distance and this distance, and as you can see we have just 1, because here we have from 0 to 1, so here we have 1, the amplitude, and you must have the same thing here. How are you going to calculate it? The amplitude equals the absolute value of A, and let's go back to our original, to our form of the trigonometric function. As you can see, this is A sine. A is the coefficient of sine, and which is the coefficient here in the function that we are plotting? Is 1, okay? So we are going to write the absolute value of 1 equals 1. So the amplitude in this graph, in this function, is 1, okay? So now you know that the amplitude is going to be from the x-axis to the maximum point is going to be 1, and also to the minimum point. Then number 2, dear students, period. Here we have a little formula that I need you to learn. This is 2 pi over b. And then here we have the letter b. Which is letter b, dear students? Is the coefficient of x. And tell me here, which is the coefficient of the function that we are plotting? 1. So we go back to our formula and we write 2 pi over 1, because b equals 1. And we get that the period is 2 pi. But what is the period? Remember, I was telling you that is when you take in account 1 crest and 1 valley, okay? And you went. This is 1 period. Quadrant. This is number 3. The quadrant, again, a little formula that I need you to learn. Period over 4. Why? Because as you remember, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. That's why we are dividing by 4 here, okay? So, we take the period, I mean, what is the measure from here, from the beginning of the period to the ending of the period? This is 2 pi, because we start in 0 pi and we end in 2 pi. So, and here we have that the period is 2 pi. So we divide 2 pi by 4 and we get pi halves when we simplify the fraction. So we know that the quadrant is going to be pi halves. This is important because this one is telling you where you are going to plot the next point. So you know that you are going to start with the table. We know that this is 0, 0. But if we don't have the table, because we are not going to have the table later on, with the next step, you are going to know where you are going to start plotting the first point, okay? So here we have, from 0 to the next point, you must have pi halves, which is this distance, okay? And then from this one to the next point, again you have pi halves. And from this one to the next one, again pi halves. And from this one to the last one, again pi halves, okay? This is the size of the quadrant, okay? Then the beginning of the cycle, we are going to get it with this other little formula, bx plus c equals 0. You don't have to learn by heart this, but it's important for you to identify that this part is exactly this part of the function, okay? Bx, what is inside the parentheses? Bx plus c. And let me tell you that c is given in pi terms. So here you are going to have, for example, 3x plus pi, okay? So you go back and then you solve for x. In this case, we have y equals sine of x. So as we don't have any c and our b is 1, look, we are going to have 1x plus 0, because we don't have any c, equals 0. This 0 is always going to be 0, okay? This one, because this is part of the formula. And why? Why 0? Because we are talking about the beginning of the cycle. That's why we equalize this one to 0. When we talk about the ending of the cycle, we equalize to 2 pi. But this is going to be always to 2 pi, and this one is going to be always to 0, okay? Pay attention to this part. Good. Now, 1x plus 0 equals 0. We have to solve for x here and also in the ending of the cycle. In this one, we get x equals 0. So now we know that we're going to start plotting the graph in x equals 0. I mean in the x-axis here, okay? And then it depends on the value for sine. For example, in this case, as we have 0 in sine, that's why we are plotting the point here in 0, okay? And then the ending of the cycle, the same thing, bx plus c. So you take whatever you have inside the parentheses and you solve for x. In this case, the same thing, 1x plus 0 equals 2 pi, and we solve for x. As you can see, we are going to get x equals 2 pi because c equals 0. So we get x equals 2 pi, and this is the ending. And as you can see, yes, we are ending the graph, the period of this graph, the graph of this function in 2 pi, okay? Now, number 6, dear students, the maximum. You just look for the point where you have the maximum point of the graph, which is this one, and you write it. In the x coordinate, you have pi halves, comma, 1, because in the y coordinate, you have 1, okay? And then minimum. You go and look for the minimum point that you have in the graph, and it is this one. So you're going to write 3 pi halves in the x coordinate and minus 1, because now you are in minus 1 in the y coordinate, okay? And then domain and range. The domain from left to right, remember that I was telling you that this wave is coming from the negative infinity and it continues going to the positive infinity. So this is just the period for this function. But the real thing is that when we talk about sine functions or cosine functions, the domain always is going to be from negative infinity to positive infinity, okay? And the range, it is very easy. From the bottom to the top, you come here from the bottom, okay? And here you have the graph. You start here, and here it is minus 1 included, okay? Because the graph takes this minus 1 in account. So you are going to write a bracket, and then minus 1 comma and then you continue going up, and here it ends in number 1 for the y-axis. So number 1 is also being included, so you close with a bracket. Okay, dear students? I hope you understand everything. If not, you can ask me in the class or in the tutoring time. And thanks for your kind attention. Later on, I'm going to explain you about the cosine function. But first, I want you to try to do it by yourself. Okay? Well, so take care, stay at home, and I send you hugs. See you tomorrow.